The graph of the function f is given here as this blue curve, green curve over here, and the graph of the function g is given over here as the blue curve, right? So the green one is f and then blue one is z, and we have to use this graph over here to evaluate the limit of this function given over here as a quotient of function f and g if it exists. Okay, so that's what we need to find out. So how can we do this? So remember, our goal here is to find the limit of this new function, which is quotient function of f and g, and we need to evaluate the limit of this function when x gets closer and closer to -1, right? So that's what we need to find it. All right, so how can we do this? If we have a quotient function, do we have some rule on the limit? Well, we do have, right? So we do have the quotient rule, which says that if we have to find the limit of the quotient function, we can actually find the limit of the top function, which is, let's say, f, so at -1, find that, right? And then also try to see if we can find the limit of the function g of x, right, when x gets closer and closer to -1. But remember, there is actually a restriction on this formula. This rule will be only valid if the denominator over here, whatever limit of the function we have, that cannot be 0. If that is 0, we cannot use the quotient rule. So if that is the case, why don't we just find these first then? Okay, so let's go closer and closer to -1 from the left and right, and then find the limit of that. So -1 is somewhere over here on the x-axis, right? So let's go closer and closer to -1 from the left side. When we do that, we can see that the y value is just getting actually look like right over somewhere over there. Is that -2? It's approaching when x gets closer and closer to -1 over here. The y values, you can see each time the y value we can measure over here, and then it's just getting closer and closer to this height over here. So that is the left side limit, which is -2. And then in the same way, when x gets closer and closer to -1 from the right side, the height of the curve is determined by that, and then still it is getting closer and closer to the same location, which is -2. So then in that case, definitely the limit of the function g at -1 is -2, and which is not zero, so we can definitely use the quotient rule. So if that is the case, let's just fill that in over here. That's interesting, and then that's nice. We were able to use the quotient rule. Now what do we just need to do? We just need to find out what is the limit of the f at -1. So let's try to go and then look into that over here. So we need to now find the limit of the function f when x gets closer and closer to -1. So -1 on the x-axis is over here. Let's go closer and closer to -1 from the left side. When we do that, the height of the curve is just getting closer and closer, right? So the height of the curve is actually getting closer and closer to, you can see the height of the curve is getting, so this is, if I am somewhere over here, the height of the curve is determined by this one, which is outside the window. I don't know what is that one, but if I am nearby this over here on the -1, then the height of the curve is somewhere like that, and then so on. So each time it's determining by this this curve over here, and then clearly when I go closer and closer to -1 from the left side, is somewhere over here will approach. The y value will approach at that location, which is what is that one? 6, right? So that is the left side limit then at -1 for this function f. But what is the right side limit? When we go closer and closer to -1 from the right side, the height of the curve is again getting closer and closer to, wow, again on the same location, which is at 6. So the left side limit and the right side limit of this function f is actually again what is that one? This is again -1, right? So on that case, the negative, whenever we go closer and closer to -1 from the left and right, on the x-axis, the y values for the function f is getting closer and closer to, what was the location? This one, right over here, 6, right? So let's have that one over here. So 6 divided by -2, that's what we get then. So that those are the limits of the individual function. We just take a quotient of that, which is now actually equal to -3. So this is the limit of the quotient of this function f and g.